Okay, today we are going to talk about using our calculator to find the area or the percentages underneath the normal distribution or the bell curve. So we have talked about going from an X scale to a Z score. So remember with the X scale, you just put the mean here, and then to figure out the numbers here, you just add on the amount for the standard deviation. And then to go this way, you minus the amounts of the standard deviation. Now the mean always translates to a z-score of 0. The first number has a z-score of 1 because it's one jump above the mean. Z-score of 2 because you're 2 jumps above. And then the areas, remember, it's symmetrical. So within one jump, you have 68%. Within 2 jumps is 95%, and within 3 jumps is 99.7. The reason why it's not 100% is that you may have outliers. Now, each of those numbers can be divided in half. So 68 would be 34 and 34. 95 is 13.5 plus 34 plus 13.5 plus 34. And then the same thing can be true for 99.7. Now, the problem that happens is what happens if I want to know the area between a z-score of 0.5 and a z-score of 1.7? What if I want to know what that percent is? So I can estimate, so since it's 0.5, I could estimate half of 34, and then 13.5, I want a little bit more than half of that. So I could estimate, but I'm not going to be able to get the exact number out, and it's about getting those exacts. So there's a button on our calculator that does exactly that. It helps us find the exact percent, okay? So it says determine the percent of data or area, so that it can be worded either way, that is shaded. There's a button on our calculator that helps us to do this. So the button on our calculator is called Normal CDF. Okay, and I'll show you where it is in just a minute. But what I want you to see here is that this is z-scores that I've given you. So again, the mean is 0. So I want you to find what percent that is between a z-score of negative 1.2 and 0.8. So I first just want to estimate it with you. So let's just draw this in here. So remember, 1, 2, negative 1, negative 2. So remember, each of these is 34%. And then from here to here is 13.5. So negative 1.2 to 0.8. So 0.8 would be right about here. So it's not going to be the full 34. Maybe let's estimate from there to there, it's going to be, let's say, 28%. And then negative 1.2 is right about here. So we're going to use the full 34 plus a tiny chunk of this 13.5. Let's say 3% of it. So I'm going to go 3 plus 34 plus 28. So that would give me, let's just see here, 34, 37, 37. So that's going to be about 65%. Okay, so that's my estimate. But again, I want to find the exact number. So how I do that is on my calculator. Okay, what you do is you hit second and you hit vars. Okay, second vars. And number 2 says normal CDF. Now, don't pick number 1. The PDF key and the CDF key are very different. So you always want to pick normal CDF. Okay. So I'm just going to write this down on here so you can have it. So you're going to go second vars. And then you're going to pick number 2 for normal CDF. So now at this point, it's asking you for the lower and the upper. So the lower is the z-score on the left. So the z-score on the left was negative 1.2. The upper is a z-score of 0.8. Now the mean is 0 because, again, we're talking about z-scores, and the standard deviation is 1. So those are just the standard numbers that we use. So then I go paste, and I just hit enter. And there it is there, 0.673. So to get the percent, I go times by 100. So I get out 67.3%. Whoops. So that is the percent between negative 1.2 and 0.8. So I estimated 65 and the actual was 67.3. So that was a pretty good estimate. Okay. Okay, let's try these ones. So I want to know the percent between the z-scores of 0.5 and 2.2. So again, I'm going to go second vars. I'm going to pick number 2. So the lower and the upper. Now the lower is always the one on the left, the upper is always the one on the right. So lower would be 0.5 and upper would be 2.2. Okay, so I'm going to go second vars. I'm going to pick number 2. So the lower is 0.5, the upper is 2.2. Go down to paste and hit enter. And there it is there. So 29 point, and then times it by 100, sorry, to get the percent. So you get out 29.5%. So just under 30% is colored in. Okay, now this one's a little trickier. So negative 1.2, but we're not given a finishing number. Okay, so I want you to understand, or try to understand, that again, remember that's 0. It goes negative 1, negative 2, negative 3, and it goes forever to negative infinity. But we don't have an infinity button on our calculator. So what you're going to do is you're just going to create a really, really, really small number. So let's just say negative 1,000. Okay, so when they don't give you an ending point, we're just going to use negative 1,000. Okay, we're just going to use a really, 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 really negative number. Now you could use 10,000, negative 10,000, negative 100,000, negative 1 million. You can use whatever tiny, tiny, tiny number that you want. Okay, so we're going to go second vars. I'm going to pick number 2. So I'm going to go negative 1. I'm just going to put a bunch of zeros. Okay, so you can use whatever number you want. You just want to make it really, 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 really negative. And then the upper number, oh shoot, I don't remember. It was negative 1.2. So negative 1.2. Go down to paste and hit enter. And so 0.115, so if I times that by 100, I get out 11.5%. Okay. Okay, now on this one, we have a similar issue where we have this here, we don't have the top number. So here you're going to use positive 1 and then as many zeros as you want, okay, a whole bunch of zeros. So you're going to go number 2, normal CDF. So again, the lower and the upper. So the lower, remember, is the one on the left and then the right. So it's 1.35 and you're just going to go 1 with a whole bunch of zeros after it. So second vars, number 2. So the lower, the upper, a bunch of zeros, paste, and then times that by 100. And so the percent is 8.85% or 8.9%. Okay. Now, what happens if we don't have the z-scores? So it says in math class on a recent test, the class average was 72% with a standard deviation of 5%. You got a mark of 76%. Okay, so class average was 72. Standard deviation was 5. You're right here, it's 76%. That's you. So that's drawing the normal distribution. We're not going to calculate the z-score. We don't need to do that. So the question says, what percent of students did you score above? Okay, so what percent of students did you score above? So you scored above most of the kids in the class because this is the class average and this is what you got. So I want to know what this percent is all the way down. So again, the lower, the upper. Okay, so what you're going to do is we're going to use normal CDF. Okay, so we're going to go the lower, the upper, the mean, and the standard deviation. Now, for the lower, remember there's no stopping, so you're going to go -1 followed by a ton of zeros. For the upper, you're going to go 76. Now for the mean, remember your calculator is set to 0 and 1, but the mean now is not 0 and 1, it's 72 and 5. Okay, so now we're actually going to plug in those numbers as well. So we're going to go second vars, number 2. So we're going to go -1 followed by a whole bunch of zeros. 76 was your score. The average was 72, and the standard deviation is 5. You go to paste, and you hit enter. Times that by 100. So the percent is 78.8%. So what that means is that in the class as a whole, you did better than 78.8% of the kids. Or in other words, 78.8% of the kids did worse than you. That's what that means. Okay, so let's look at this one. A cold virus, on average, lasts for 5 days. So on average, the cold virus lasts for 5 days with a standard deviation of 2 days. You're sick for 8 days. That's you right there. So again, we're not going to worry about calculating the Z-score. The question says, what percent of people will have a cold longer than 8 days? So longer than 8 days is everything here. So for normal CDF, so remember it goes lower, upper, mean, and standard deviation. So the lower is 8. The upper, remember there was no stopping it, so it was 1 with a whole bunch of zeros. The mean is 5 days, and the standard deviation is 2. Okay, so we're just going to use our calculator again. So again, second vars, number 2. So 8, 1, followed by a whole bunch of zeros, 5, and 2. Times it by 100. So how many people will have a cold lasting longer than 8 days? 6.7%. 6.7% of the people will have colds that last longer than 8 days. Okay, let's do one more. The average lifespan of a certain brand of battery is 18 months. So the average is 18 months with a standard deviation of 3 months. Okay. What percent of batteries should last between 12 months, so 12 is less than 18, and 19 months. 19 is a little bit bigger than 18. So it's wanting to know what's that percent. So we're going to go normal CDF. So the lower, the upper, the mean, and the standard deviation. So the lower is the left, the upper is the right, the mean is the number in the middle, and the standard deviation is what you're counting by. Okay, so 12, 19, 18, 3. And then we're going to times that by 100. So 60.8% of batteries, so just under 61% of batteries, should last between 12 and 19 months. Okay, so try the questions on the assignment. If you get stuck, you're always welcome to ask, and I will see you in the next video. Take care.